drive?
Almost.
All right, so we got four-wheel drive here we're talking about, and this is not so terribly strong there. You got mono beam axle and independent front suspension, so you got a one-piece design. So whatever happens over here is going to affect that over there. If you got just a straight axle across there, whether it's front-wheel drive or rear-wheel drive, I mean, or not front-wheel, excuse me. If it's four-wheel drive or not four-wheel drive, you can have independent front suspension, or you can have just that one axle going across. And so basically, you know, you're going to be looking at real heavy-duty stuff. This is what independent front suspension's about. Whenever this one's bouncing up and down over here, it doesn't affect that one over there. Now this is bolted solidly to the frame, and your springs are actually connected out here. That's typically where that's going. Okay, so you got the same components such as rear-wheel drive. Got a transfer case, front drive shaft, front drive axle. This is additional components you're going to have on four-wheel drive. And there's your transfer case. Okay, so somebody tell me what this is right here. Anybody know what that is?
Different transfer case.
Huh?
Transfer case.
No, I mean this is, but what's that part of it?
7 or 8 more here, 3 or 4 over here. We can get them all in. I know I'm interrupting, but I'm fixing to go to lunch.
Yeah. Yep. What you got there?
About 30 deer feeding in front.
Well, that's smooth.
Where's that at, Gene?
Yeah.
It's just a little piece of nothing farm up that.
Yeah. All right.
Don't let
So.
nobody tell you you can't do a lot on 30 acres, okay?
All right. So part-time transfer cases may be shifted electronically. That thing I was pointing at on that transfer case is the transfer case shift motor. The transfer case shift motor basically tells it the electronic transfer case stuff is more complicated than you think. And the transfer case shift motor is almost like a glorified wiper motor, because you know, like a wiper motor's got a park switch in it and all that. Well, on the transfer case shift motor, it needs to be able to, I mean, the module that's operating it, whether it's the gem module or the standalone module or the PCM or whatever, needs to know where that shift motor is so it'll know what gear you're in and all that. And so, come on in here, Zach. Come on. To get you all welded up. Yes. All right. All right. Part-time four-wheel drive system, and the ones with a part-time transfer case operate the same as two-wheel drive when four-wheel drive is not engaged. Now, if you have four-wheel drive engaged on one of these kind of setups, and you've got tires that aren't exactly the same size, you know, your front and your rear differential have got to be exactly the same ratio. You cannot have, you're not supposed to drive it on dry pavement, because what happens is it tries to bind up and everything. I had a Bronco I was working on one time at the dealership, and I went to back it out of there, and it bound up on me when I was backing out. When I pulled it back up, it unbound, and somehow it had got bumped into four-wheel drive. And we'll pay kind of close attention to that, don't tear anything up. So you got full-time transfer case systems are always in a four-wheel drive mode and can't be controlled by the driver. The front drive line is always engaged and maintains constant power to the front and rear axles. These a lot of the little small cars, the sporty cars that you see will have all-wheel drive on them like that, and those things will stick to the road like glue. If you're ever driving one of those, you know, those guys told me taking a 15-mile-an-hour curve at 70 miles an hour and it just sticks to the road. But a lot of, you know, you can also have SUVs that are set up that way. The full-time transfer case has got a center differential or an interaxle differential between the front and rear output shafts. And the vehicle with a full-time transfer case will not perform like a two-wheel drive. This chain in here, and I got 2 transfer cases over there that we like to tear apart and put back together in drive line. You're going to get a worksheet on that sooner or later. One of them's an electric transfer case, and the other one just a plain old transfer case. And one came out of a Dodge New Process transfer case, and the other one from a GM of some kind. But one way or another, this is how it's put together on the inside. You got a driven sprocket, interlock up hub. There is something missing from this that you actually have on a transfer case that you wouldn't, some of you might not ever even expect. But you notice you got your, you got shift forks, which is very similar to a transmission, and then you got output shaft, you got planetary gear sets. Why would you need a planetary gear set in a transfer case? What you guys watching on that phone? Do we need to put it on a big screen so we can all watch it? All right. So what do you think? Why do we need a planetary gear set in a transfer case?
Does it give you the four-wheel drive?
Well, it doesn't give you the four-wheel drive, but it gives you low gear. It gives you four-wheel load. Is what it does. For the planetary gear set, it's going to give you another gear ratio that you wouldn't ordinarily have. All right. Now the transfer case has got a big chain. I just showed you a picture of that a while ago, like a big, you know, like a timing chain just about. Transfer power from the front and output shaft. Now you might notice how they stack this chain together and they laminate it and put those pins in there. The reason they do that, like the older timing chain, is because it's quieter than something like a vault, you know, like a bicycle chain or something, or roller chain. Okay, so basically, what is this right here? Is this the input or the output? Okay, how do you know?
Is, change that, that's your output going to the front, ain't it?
This hooks to the front, that's
That's
right,
what
that
I'm
drive
saying.
shaft, that drive shaft goes to the front,
So
this
that-
goes to the rear drive shaft, and you notice it's turning that way, it's turning clockwise. And so whenever you're going forward, your drive line is gonna turn clockwise in a linear, you know, drive line. You know, in other words, I say that, whenever you're looking at it from this direction, it's turning clockwise. When you're sitting in the vehicle, you know, to you, it will be turning counterclockwise, but if you're looking at the front of the engine, you can always remember, unless the engine is a front-wheel drive car and the motor's in there backwards, like some of these little Hondas, you're always gonna have the thing turning, if you're looking at the front of the engine, it'll be turning clockwise, and all that. But anyway, and so basically you got a shift collar right here, and all that, you got two shift collars actually. All right, so there's three ways for it to flow through: two-wheel high, and four-wheel low. Okay, you got a input shaft which is connected to your sun gear. You got a reduction hub right there. You got a rear output shaft. Pretty good. See, this is going out in the drive shaft in the back, and there's a little shift collar. Okay, when the vehicle's in two-wheel high, the reduction hub slides forward and engages the internal splines with the external splines on the end of the input shaft, so it's a sort of a straight-through thing right there. See, but you don't necessarily be, you're not driving anything up here yet. That locks the input shaft to the rear output shaft. It's a straight through, kind of like your high gear, you know, your fourth gear in the transmission we were looking at last semester. Okay, if the splines of the reduction hub and the input shaft become butted, which prevent engagement, the helical spring at the base of the shaft will maintain shaft pressure, and that snaps it in. That allows the component to engage once the input shaft rotates. That's why that's on there. You know, a lot of times when you're putting something like this together, if you're putting it back together and you've got a part and you're not exactly sure why it's there, you know, you basically need to put it all back together like it was. So pay attention to it when you take it apart, because there may not be somebody laying around anywhere that has memorized this, you know. Or you're working at a shop where there's a lot of people, you know, sometimes you'll have somebody like that, but if you're on your own, you're on your own. Interlock up hub, drive sprocket. If you're like me, you're self-reliant, you don't have like asking for help. Okay, so basically when you're in four-wheel drive high, you're basically going to snap that in. You see how that works? See that? You got your reduction hub there, which is basically staying there. All right, and then see, remember you got a chain between these. You got a drive sprocket and a driven sprocket, but you haven't engaged your planetary gear set to give you your doggone reduction from the planetary gear set. When it's put in gear, torque's transmitted into the transfer case input shaft from the transmission output shaft, which is right here. And then basically you're going to be, in this four-wheel drive high, you're feeding this because that's snapped over here and it's got that engaged, so it's actually, you got torque coming this way. Okay, the reduction hub connects the input shaft to the rear output shaft, torque transmitted to the rear axle, it goes out that way, and it's all coming this way. In extreme cases, I have known of people, like if they had a problem with the rear end on their vehicle where this wouldn't work, they would take that rear drive shaft out and just keep it in four-wheel drive and drive it with the front. You know, I mean, that's doable. You can make it happen if you have to, you know. When four-wheel drive is selected, a lock-up collar moves and locks the inner lock-up hub, so you have to snap it up here. Basically, you're getting that. All right, the inner lock-up hub locks the drive sprocket locks the rear output shaft. Okay, so there's your rear output shaft. The rear output shaft locked to the drive sprocket, torque also transmitted to the front axle, once again through here, and so on and so forth. Now, four-wheel drive low, you got something different going on. The reduction hub moves onto the planetary carrier, and that locks the planetary carrier to the rear output shaft, which is good there. You remember what I told you guys about this guy? It was last semester that had a F-150, or that he had four-wheel drive, that it was shifted into its highest gear before you even got going 25 miles an hour. And the reason it was doing that was because the PCM thought it was in four-wheel low, because the indicator light on the dash wasn't getting any power. And because of that, The way that the PCM would tell it was in four-wheel low is it would look to see if there wasn't any voltage coming through that indicator light. The indicator light, there was a blown fuse or something. But it basically, the PCM will say, well, I'm in four-wheel low, so I need to operate a shift schedule so that whenever, you know, we shift into the highest gear, we're still going really slow. And he had rebuilt the transmission trying to fix that, but he didn't think about the fact that, you know, how does it know it's in four-wheel low? That's what I'd be, you know, we're looking at. We put a fuse in there and fix that one. Okay, so when it's put in gear, torque's rotated through the planetary pinion gears. The pinion gears walk around the inside of the ring gear, causes the planetary carrier and the rear output shaft to rotate in reduction to the input shaft. So basically, you've got this turning a lot faster than that. See what I mean? This is actually turning, well, you got this turning faster than that, you're basically in a lower gear. It's got more torque to be transferred through the transfer case, which is pretty handy. The one thing that's missing out of these, and I don't think this PowerPoint even talks about it, is a transfer case has an oil pump in it. It has to have an oil pump so it can keep it lubricated. Now it's a skinny little oil pump, don't look like much, it's not as thick as the one that you see on a transmission or an engine, but it does have an oil pump in it. All right, so with the interlock up hub locked to the drive sprocket, torque is not transmitted to the front differential. You'll understand this a little better if you're paying attention when you tear these transfer cases down, because you'll see this stuff I'm talking about. And although there's some, you know, electrical parts in the one that's electric transfer case. Okay, through the drive chain, driven sprocket, and front output shaft. Okay, so you got some mechanical components here. There's your planetary gears. Now, what part is this right here? Can anybody pick that out? That's actually the pinion. I mean the planet pinion carrier. This is the sun gear, and that's the ring gear on that. That's the way it's all split apart right there. See right there, you got these little gears in here that mesh with that and that, and that gives it torque multiplication in four-wheel drive load. And, you know, in part-time transfer cases, the planetary gears are driven by the input shaft or the sun gear. This is basically coming from the transmission. All right, the planetary gears walk around the inside of the ring gear, which is held stationary in the case. And the result is the planetary carrier turns more slowly than the input shaft. So they're walking around this, and so it's attached directly to the output shaft through the reduction hub. Then you've basically got a lower speed on the output than you do the input, and that makes the engine torque available, you know, through there. I got to go through this pretty quick because I got a lot of slides. Okay. All right. So you got chains and sprockets in there. You know, that's what they look like right there. And this is going to the front. This is coming in from the transmission, and that's going out the back. All right. So it's got this really high efficiency drive chain. I still got a photo of one to start with. There's a drive sprocket on the rear output shaft and drives a driven sprocket on the front one. And if you've got two-wheel drive, four-wheel drive, there's a fork there. Moves the lockup collar to engage the drive sprocket to the rear spline. Like I say, you'll see this. When you tear the transfer cases apart, you'll understand this better. This is just a quick overview. The drive sprocket turns the chain, that turns the driven sprocket to the front output shaft, which goes to the front differential. On all-wheel drive transfer cases, the output from the planetary gear set enters the viscous coupling. What's a viscous coupling? Somebody tell me. Do all four-wheel drive vehicles have a viscous coupling? Yes or no? We're going to learn about a viscous coupling in a minute. All right, so we got different clutch types, clutch pack, cam coil, housing assemblies, and all that. See, there's a bunch of different ways these things work. Okay, so your clutch pack and your cam coil housing assemblies right here. What does that look like to you? What does it remind you of? AC clutch, right? Like you got that. You'll see that when you tear that other transfer case apart. You got some clutches in there, clutch packing. That'll remind you of an automatic transmission, but you got this right. You got this clutch right here, and it electrically bites all of those things instead of using hydraulics. So if it's energized, see, here's your clutch. It's energized. It's actually biting this. So what's splined to the inside, what's splined to the outside is now one piece, which is pretty cool stuff. The way they did that. Actually, it was not applied in that first picture. And I screwed up on that. It's energizing, but it hadn't applied yet. And there it's applied. See how it's moving that forward? Okay. So the control module uses torque on demand relay to activate. Now this is automatic four-wheel drive. You ever heard of automatic four-wheel drive? You ever heard of that on anything?
Yeah.
You have no control over it. You cannot determine if it's in four-wheel drive or not. I mean, you can't tell it to go into four-wheel drive. It's going to go into four-wheel drive when it needs it, and you don't have anything to say about it. And I used to see this, the first vehicle I saw this on, I thought it was mighty peculiar. I had a Ford Aerostar that I raised up on the lift one day, and I noticed, golly, this thing's got a transfer case and everything for four-wheel drive, but I didn't see nothing about four-wheel drive in there. But it's got a little module under the seat, a little bitty electronic module about the size of a pack of cigarettes, and it actually, we'll talk about that right here, you know. So it senses a difference in the front output shaft speed versus the rear output shaft speed, and that eliminates slip. So if you actually it detects that some of the wheels are spinning, it throws it into four-wheel drive so you can, you know, pull off. So you basically got a little duty cycle stuff you're going on with that. Duty cycle meaning it's turning it on part of the time and off part of the time. Increased under heavy throttle and off throttle conditions, vehicle speeds above 50 kilometers per hour. And when the control module activates a torque on demand relay, the relay provides battery power to the clutch coil. The clutch coil magnetically pulls the armature against the cam coil housing assembly and makes it bite and all that. And so basically you got a front axle speed sensor, a rear axle speed sensor, transfer case, clutch solenoid, and this is just the wiring for it, basically. All right, so on the inside of the cam coil housing assembly, half of a ball and cam assembly. Well, basically, if you got a ball and cam assembly, you got the balls that ride in little dimples, and when they roll up those ramps, you know, it basically makes it fight. The other thing that I've seen that operates that way is some of the rear, you know, these rear park and brake assemblies you got to screw in when you're putting brake pads on the rear. Inside there, they've got a ball and cam thing. So when you pull the park brake, it actually rolls those little balls up out of their ramps and bites the rear, which is different from the way this Miata works, by the way. And so anyway, that's how it is. The two cams turn at different speeds, cause the balls to ramp up on the cam. That's what we're talking about there. And that pushes the cam against the pressure plate, squeezes the clutch pack. So when it squeezes the clutch pack, the clutch pump links the clutch housing, transfers torque to front output shaft. So you get your clutch coil in there. And electronic ones work pretty much the same way, except they're not automatic. You know, you push the button and all. You get an air conditioner compressor clutch, you know. Air conditioner compressor clutch got about 10 ohms resistance. You might remember that for that purpose. There's your shift motor. That's what I was talking about earlier on that. Electromagnetic clutch controlled by the module through a solid state relay. The clutch is used to spin up the front drive system from 0 to vehicle speed really fast. And that spin up engages the front lock and hubs. After that's been accomplished, the module allows the shift motor to execute the shift. All right. Transfer case rear and front output shaft reach synchronous speed. It means they're dependent at the same. The spring-loaded synchronizer sleeve mechanically engages the main shaft lockup hub to the chain drive sprocket, and the magnetic clutch is activated. So you got basically full-time four-wheel drive vehicles that got a viscous coupling. All right, so that's what we're going to talk about here now. The purpose of it, this keeps the thing from winding up. You know, when I told you put it in four-wheel drive, if you're driving on hard pavement or the tires are a different size or whatever, it binds up. The viscous coupling supplies power without actually being totally, it allows slippage. And the closest thing I can tell you to, you know, the fan clutch is a viscous coupling. And it basically gets harder to turn with heat. So when it starts to get out, or actually you got someone like that one laying up right, it's got wires on it. So when the PCM can actually engage the viscous coupling on that one and make it harder to turn, and so that the fan speed will more closely match that of the engine. Okay, so regardless, it provides torque to the wheel regardless of the traction available to the tire. So this right here is basically an all-wheel drive thing, and it helps you in snow and mud and all that kind of thing. So it's similar to multi-disc clutches using automatic transmissions. It's in a sealed housing. This fluid, you know, is basically trapped in there. Unlike the clutch disc in an automatic transmission, they don't have conventional friction material on their surfaces, but they got a ferric nitrocarburized coating. Remember that, it's going to be on a pop test. You're going to have to spell it right and everything. One set of discs is connected to the coupling housing, which is connected to the planetary gear ring. The other set is connected to the internal hub of the coupling, which is connected to the planetary sun gear. And basically now whenever somebody talks about a viscous coupling, you'll know what they're talking about. Whenever you see this, it basically provides resistance so that this thing can actually provide torque, but allow slippage when it's needed to be. The drive plates are held in a fixed position. How they can't move either horizontally or vertically, and the driven plates are splined to the inner hub to prevent vertical movement, but they're not held in place horizontally. So if they're splined, they can float. See, basically when extreme pressure builds up, they can slide. So basically that's what they're able to do. Now that's a direct mechanical coupling, but it basically doesn't cause it to wind up and everything, so it doesn't hurt anything, right? It can actually provide traction, but it's not going to tear itself apart. And that's what the viscous coupling is all about. But if the plates become warped, you may have the coupling may fail and it has to be replaced, you know. All right, so lock and wheel hub operation. Now this right here, Justin, we got brand new kits come in to put on the Bronco out there, you know, the ones that are manual locking. And that's what's pictured right here. You see that exploded view? And so they're used to engage and disengage the front wheels. I know one guy, he's already passed away now, but he had an 18-year-old son that got out to lock the hub so that they could use four-wheel drive. And because he was out of the truck rolled over on him and killed him. So it's best not to have to get out and lock the hubs if you can, you know, not have to do that. Basically, it's better to be able to lock them internally. When they're actuated, the hub body locks the hub in a wheel assembly. So basically what you don't want is you don't want your front differential whirling all the time when it's not being used to pull, because it wears things out, right? It also causes more power to be needed to drive the vehicle down the road. Well, there's three times. You got manual, automatic, and vacuum, okay? Now the locking axles right here, the way this is my favorite way of doing this. This thing right here is actually hooked into that, you know, front hub, and it spins freely whenever you don't need four-wheel drive. But whenever this is either electrical or vacuum, we'll actually slide this collar forward, and I just sort of slid that forward, took a picture of it, so that it basically causes the torque that's coming out of the front differential to go out to the hub, but it's done inside there. And it's really simple the way it works. There's one laying on the bench over there, and that's what the locking axle. I really like this one better than the self-locking hubs like the Bronco's got on, where it's not self-locking, it's the one that you do that. Okay, the manual hub's got a clutch that's shifted by rotating a portion of the hub, which is what you've done, a little red knob in there. The hub engages with an internal cam, moves the spline onto the clutch hub, so it meshes with the spline on the wheel hub. And automatic hubs have got a feature in which rotation of the axle causes the cam in the hub to operate, and that lets the driver engage in four-wheel drive without having to go to the hub to lock them. So basically, when you put it in four-wheel drive, they automatically lock. But when you take it out of four-wheel drive, you got to back up the length of the pickup truck to let it release. Are you familiar with that? You done that before? If you don't do that, they stay locked, and so you're actually, you know, causing issues and all that. So this PVH system, pulse vacuum hub lock system, is a wheel and disconnect. And some of these actually use vacuum out here in the end of the hub and all that. Disengages the hub from the front axle half shaft using a vacuum from the engine, then take manifold. Now, there is a tool. I had this Ranger we had to do wheel bearings on, and this hub that's on here for the four-wheel drive, you will not get it off of there without a $100 special tool. There ain't no way. And I bought one of those tools and used it on that one truck so we could replace a wheel bearing on it. And I can show it to you. I mean, I got a picture of it. I mean, I actually got the tool over here, but I feel like it's a 94 or 5 Ranger that we had to do that on. And it hooks in 6 different places around there, and you just put it on there and you just bump it really gently with a slide hammer and it pops off. There ain't no way you can get it off without destroying it if you don't have a special tool. More about that later. When the driver engages or disengages a 4x4, the control module intertimes that solenoid and applies one of these vacuum, you know, basically it uses vacuum that's trapped in there so that it can't get out and it pulls it in that way. As long as you can look this stuff up when you're working on one. There needs to be no overlap between hub lock engagement, disengagement levels and solenoid disengagement, so that ensures proper 4x4 function during shift on the fly. That's whenever you're hitting whenever you're spinning and you say we need four-wheel drive, you hit it and it, you know, locks in there. Okay, so before performing any diagnostics, you got to do a pre-drive check to ensure the vehicle is relatively safe to drive and eliminate any obvious faults on the vehicle. If there's something that's obviously wrong with it, you need to look at that first. All right, and the basic outline for effective troubleshooting of any automotive system is determine the symptom, determine which systems can cause the symptom, identify the faulty components, and find the cause of the failure. Can you think of a time you've done that recently?
Brakes on the arm.
Yeah. And basically you're looking at what there? What do you think's going on?
Something's
Inside,
causing
the
them to lose.
lever, something got to do from the lever to.
Well, those cables were sticking. One of those cables was sticking pretty bad. You know, and that's why I had, as a matter of fact, the shop manual says to pull those cables off and lubricate it with gear oil. So basically, you know, we kind of know there's a problem with that, but what is the problem? And one of the, I was thinking to start with is they're wearing down the brake pads.
When you let off, the cable stuck and it stayed stuck.
Yeah, or something, but it wasn't, because I got brand new brake pads and they're exactly the same thickness as the ones on the car, and he's had them on there for a while. So the brake pads aren't wearing, causing it to lose its adjustment because it's got too much movement. You know, so there's something else going on. You know, so we have to try to track that down.
Stretched out.
You don't know if you fixed it or not until you put it all back together, and he drives it for 10 days. And if he drives it for 10 days and the park brakes are got loose again, you know, we're back to square one. But anyway, you basically, one way or another, you got to determine what is the symptom. Sometimes you need a customer to ride with you on that because you may not be able to feel it, what they're talking about. Let me tell you something else while we're talking about drive lines, because I got a minute or two here. You may run into a situation like I ran into a couple of times over there where somebody is listed as some kind of a noise. They say, well, I got a noise, I got a, you know, this whatever. And so the service advisor hands me the ticket and I go drive the thing and I hear a noise that I don't like. And I work on this thing for an hour and a half, getting rid of that noise, straightening whatever out, you know, making some kind of little tweak or adjustment or something like that. And then the customer drives the car and they'll say, oh, I heard that noise. That's not the one I was concerned about. I was worried about this other noise over here. And it was one that I didn't even think was a big deal. So I burned a couple of hours working on something. So a lot of times if you're working on a noise or something crazy that you can't feel, sometimes you got to get the customer to ride with you. So you can say, show me what you're talking about. You know, and a lot of times they say, well, it's not doing it right now. Well, see, what I'm saying is you can waste a lot of your energy and your work working on something that wasn't what they were complaining about. You get what I'm saying? I mean, and that's one of the things right there. And there's a noise, vibration, and harshness presentation that we'll give you guys too, because if you've got one, they've actually got it. I never have bought one here because they're so expensive. But there's an electronic vibration analyzer where if you got a vibration that you're trying to figure out, you're basically supposed to throw a vibration sensor on something that's vibrating like a sun visor or something, and when it gives you the frequency of the vibration, you've already figured how fast everything's turning, you know, how fast the engine's turning, how fast the car is going, how fast the drive shaft's turning, whether it's a first or a second order vibration. And by the frequency, you can tell that, you know, this frequency has got to be related to something that's spinning about the same speed as the alternator. You know what I mean? Because whenever it matches up like that, it's, you know, somewhat complicated, but whenever you figure that. If I've got how many feet are there in a mile?
5,280.
Yeah, 5,280. So if I've got a tire that all the way around it is 10 feet, how many times does it roll in a mile?
5,208.
Yeah, 528. Yeah, to remove the zero, you're doing it the right way. Now, one day when I asked a bunch of people in there, they were getting their calculators out. But what happened was, if you're driving along and you're going 60 miles an hour, you can calculate the speed of that wheel, right? And if the speed of that wheel, if it's first order vibration, you can tell from the speed of that wheel and the vibration frequency. A lot of times you just feel it. You can, like when you did the drive shaft balance, it felt a specific, you know, the drive shaft balance is the drive shaft spinning faster or slower than the wheels?
Slow.
Huh? Think about what you're saying now.
Slow.
Huh?
Slow.
Is it?
Should be.
A lot faster and all that. And right before he quit, I got this story about a drive shaft. This guy comes in there and he says, I just bought this brand new truck and the drive shaft is rusty and I don't like it. And they said, well, they don't paint the drive shaft. They just let it rust. You know, that was back when he had steel drive shaft. Now most of them are aluminum. They cost about $1,000 when you buy a drive shaft for aluminum. But anyway, I overheard him talking out there. And I said, I can fix that or he'll be happy. And I won't even charge anything because this is going to be fun. He said, okay, take it back there. So I took it back there and jacked it up, put it on jack stands because I worked in a flat stall because most of what I did was drive built-in fuel injection, all that junk. So I raised it up and I put it in gear, and with the drive shaft spinning, I rolled it over there on a creeper and I went down the drive shaft with a wire brush. Just got it all clean, just real pretty and clean. Then I blew all that dust off and wiped it off real good and cleaned it up with some lacquer thinner. And then I cranked it up and let it spin again. I got me a can of black paint. Made a beautiful, perfect paint job on that thing. That guy was happy as the Lord. Now we didn't do that to all the trucks, but that guy left out of there happy. Didn't cost him anything or nothing. See, technically, they're not going to pay you for painting a drive shaft because they don't even paint them in the factory. You know what I mean? Why does the drive shaft need to be painted? And, there was this one guy that had the transmission guy, did a bunch of transmission work on his car, and he came back complaining that the guy had greasy handprints on the cross member under the car. he looked under there and saw greasy handprints on the cross member and didn't like it and wanted to clean that off, you know, as if anybody could see that. Anyway, okay. Somebody tell me something you learned that you didn't know before.
Viscous.
They were 10 feet to a tire.
Huh?
They were 10 feet to a tire.
10 feet to a tire. No, not every tire. It's different for different tires. Incidentally, on my website, there's a calculator that you can use if you had a different size tire than you're putting on there, it will tell you what the difference in speed is. There's a web about there, if you look at, there's a tire size calculator, pretty cool, because you need to know that sometimes. You know, anyway. All right.
That's a wheel